This is the first video for sections D to H of the trigonometry module. In this video we're looking at the trigonometric ratios. Now you need to remember that the study of trigonometry is based on ratios between the side lengths of right-angled triangles. Okay, the fundamental ratios are sine, cosine and tangent, and these ratios are defined for a specified angle theta. So you can see in my diagram here that opposite the right angle is a hypotenuse. Opposite my specified angle, which is theta, is my opposite, and the other side is my adjacent. Now our trig ratios can be summarized using the word SOHCAHTOA. Okay, that's the easiest way to remember it, I think. There are mnemonics which are in your textbook, but SOHCAHTOA is easy. And what SOHCAHTOA says is, if we look at the SOH of the SOHCAHTOA, it's saying that sine is opposite over hypotenuse. So you can see this here, sine theta is opposite over hypotenuse, or abbreviated, sine theta is O over H. That K of SOHCAHTOA is saying that cos is adjacent over hypotenuse. So cos theta is adjacent over hypotenuse. Abbreviated, cos theta is A over H. Then we've got TOA, which is saying that tan is opposite over adjacent. So tan theta is opposite over adjacent, or abbreviated, tan theta is O over H. Now note, these never change. They always stay like that. So remember SOHCAHTOA, and you can't forget your trig ratios. Sine, opposite over hypotenuse. Cos, adjacent over hypotenuse. Tan, opposite over adjacent. Okay? Now, whereas the textbook addresses each trig ratio in turn across a number of exercises, this video is going to address them all in one go. Okay, so we're going to start by looking at finding sides. Now, in a right-angled triangle, if we are given another angle and a side, we can find the third angle using the angle sum of a triangle, or the other side using trigonometry. So let's look at some examples here. It's got find the unknown length in each of the following to 2 decimal places. So what you need to do is you need to start by labeling your triangle. So my given angle is this 67. So I go across from it, and that has to be my opposite side. Then I go from my right angle, and opposite it is my hypotenuse. So that means the side that's left is my adjacent. I then look at what sides have information. I have that this 12.8, which is my hypotenuse, and I have this unknown side, which is my x, which is my opposite. So what I'm dealing with is O and H. So if I think about SOHCAHTOA, O and H is sine. So I write it out. Well, sine theta is opposite over hypotenuse. Then I plug in the information. Sine 67 is opposite, which is my x, over hypotenuse, which is my 12.8. To get rid of that 12.8, it's being divided, so I multiply. So 12.8 sine 67 has to equal x. Plug that into your calculator. 12.8 times sine 67. Okay, and you get that x is approximately 11.78 centimeters. Now, if you're not getting that answer, make sure your calculator's in degrees. So you have to have a little d or a DEG at the top of your calculator. If it's not, if it's in rads or radians, you need to change it. Okay, let's look at another example. In this one, here's my angle, which is 39. So opposite that angle is my opposite. Go across from the right angle, and we get my hypotenuse, and my other side is adjacent. Look at what you've been given. My unknown side is the opposite, and my given side, which is the 8 meters, is my adjacent. So here I'm looking at O and A. So that has to be the TOA part, O and A, which is tan. So I then write out tan theta is opposite over adjacent. Okay? From there, plug in what I've got. Tan of 39 is my opposite is my x, my adjacent is my 8. I need to get rid of that 8. X is being divided by 8, so I multiply. So x is going to be 8 times tan of 39. Plug that into your calculator, and you get approximately 6.48, and the units is meters. Okay, next. Here's my given angle. So I'll go across from that, and there's my opposite. go across from the right angle, that's my hypotenuse, and my other side has to be my adjacent. Look at what I've been given. My 6.3 centimeters goes with my adjacent, and my unknown, my x, goes with my hypotenuse. So I'm looking at A and H. If you haven't learnt it yet, let's write SOHCAHTOA up the top here. So I've got A and H. I go across, A and H is here, so that must be cos. So I write that out. I've got cos theta equals A over H. It's always the first letter divided by the second letter. Plug in what I've got. Cos of 52, my angle is 52, equals the adjacent, which is a 6.3, over my hypotenuse, which is my x. Now I need to get this x up to there. What we do is we just swap these over. So x becomes 6.3 over cos 52. Plug that into your calculator. So you've got 6.3 divided by cos of 52, and you get approximately 10.23 centimeters. Okay, next, here's my angle. Go across from it, there's my opposite. There's my right angle. Go across from it, that's hypotenuse, so the one that's left over is adjacent. What have I been given? 12 centimeters goes with my opposite, and the unknown is my hypotenuse. So I've got O and H. Look across here, O and H are there, so that's my sine. So I write sine theta equals O over H. Sine 35 equals my opposite is 12 over my hypotenuse, which is x. The x is on the bottom, so we swap. So now I've got x equals 12 over sine 35. Plug that into my calculator and I get approximately 20.92 centimeters. Okay, go over these again. Make sure you understand it. There's lots of examples in the textbook to have a look at. Now let's find some angles. Okay, same deal. The easiest way to do these is label. Okay, it says to find them to one decimal place as well. So, opposite the theta, my given angle, I put an O. Then I have a right angle, so that's my hypotenuse, and my other side is my adjacent. Okay, so here I've got the opposites being given and the adjacents being given. So I'm going to write my ratio across. SOHCAHTOA. O and A is tan. So tan theta equals opposite over adjacent. Plug in. I don't have the angle. The opposite is 5. The adjacent is 7. Now I need to get that theta on its own, and what I do is to move the tan across to here, it becomes inverse tan, so tan to the minus 1 of 5 over 7. And on your calculator you should see the tan to the minus 1 in a different colour above the tan button. So it means you have to press your shift or your inverse key and then your tan. Okay, also remember that it's 5 divided by 7. So when you go shift tan, put in a bracket, 5 divided by 7, then close your bracket. Okay, otherwise you're only doing inverse tan of 5. So plug that into your calculator and you get approximately 35.5 degrees because we're going to one decimal point. Let's look at the next one. Well, we have a beta instead of a theta, but that doesn't matter. Go across from that, there's my opposite. Start at my right angle, go across, there's my hypotenuse. The other side is my adjacent. What have we got? 5.2 is hypotenuse, 2.7 is adjacent, so A and H. Look across here, A and H is cos. So I write out cos theta equals A over H. Cos, in this case it's a beta, so I just write that there. A adjacent is 2.7, hypotenuse is 5.2. To get beta on its own, I take the cos over and it becomes an inverse. 2.7 over 5.2. So in your calculator, you shift or your inverse button, cos, which will be inverse cos, bracket 2.7 divided by 5.2, close your bracket, and you get approximately 58.7 degrees. Let's do a couple more. In this one, we're finding alpha. So I start at my alpha and I go across, and there's my opposite. My right angle, go across, and there's my hypotenuse. And my third side is my adjacent. What have I been given? I've got hypotenuse as 9.4 and I've got opposite, which is 7.1. Again, we're dealing with SOHCAHTOA. Put it on your page if you need to. O and H. O and H is sine. So I go sine theta equals O over H. Sine, in this case, it's alpha. My opposite is 7.1. My hypotenuse is 9.4. To get alpha on its own, take the sine across and it becomes inverse sine, 7.1 over 9.4. Plug that on your calculator and you get approximately 49.1 degree. Okay, next, label. Opposite the x is the opposite. From your right angle is your hypotenuse, so your other side is adjacent. What have you been given? 28 is opposite and 18 is adjacent. So O and A, which is tan. So I write it out. Tan theta equals O over A. In this case it's an x, so tan x equals O. 28 over A is 18. Get x on its own, I take the tan across and it becomes an inverse. 28 over 18. Plug that into your calculator and you get 57.3 degrees approximately. Okay, so in this video we haven't looked at any application questions. So when you go to practice, only do questions 1 to 4. Okay, and the exercises are Trig E1, Trig F1 and Trig G1. Okay, we haven't done worded problems yet. That's covered in the next video.